Okay, then I think that we can start, and I start with welcoming you. I hope it's correct. Dzień dobry I God, I trained it. You got. Dzień dobry I zapraszam na moje sesje. Miło jest wrócić do Wrocławia. Is that okay? But you see, but you see, my English is way better than pronunciation of Polish language. My wife is from Poland, and she's quite annoying when we are lying sleepless in the bed, and I say to her, train me a little bit of Polish language. She said, go and sleep. So that's the reason why I have to talk now in English. I hope it's okay for you. So we are talking about user-defined function. Oops. Everything's okay? Yeah? It's the vodka, huh? Okay, so we are talking about user-defined functions and their development since SQL Server 2000 up to now to SQL Server 2022. People who know me know that presentation is not the style I want to have. I like to have demos. So you will see lots of demos here with the old style functions and with the new improvement they made in the functions. Just before we start, raise your hands. Who is developer here? Oh, the most of you, that's so cool. Okay, you're a DBA, you're a DBA. Feel welcome. Who is working with user-defined functions in data? Oh, so much people. Hoo-hoo. Maybe I convince you not to use them. Maybe, okay? So as long as it's not inline functions. However, first of all, a big thank you to all the sponsors here to this great conference here. I think you all know that without these sponsors, it will not be possible to make this kind of conferences happening, especially when it comes to traveling and all this kind of stuff. So that was a commercial thing. Oh, super. Is that vodka? No? Oh, so sorry for this. So my name is Ricken. I'm a German guy. I'm a so-called Uhu. It's called. That's great, yeah. I'm a so-called Uhu. That means I'm under 100, but I'm over 60. So I finished my 60th year this year in February, but I enjoy speaking all around the world, conferences, and one of my highlights is every single year, Poland, Wrocławia. Wrocław? Yeah, okay. My wife is from Opole. So if you have any questions concerning this topic or any engine-related topics, feel free to drop me an email, and that's all of commercial things. If you want to download my session or want to replay my session, the scripts can be downloaded here, but don't worry about this. I will send the full scripts, everything here to the organizers that they can distribute it to the attendees. Well, this is our agenda. What are user-defined functions? We go very quick about that because I think that most of you are familiar with this. I want to explain to you the limitations we have with user-defined functions, and then we come to the different types of user-defined functions. We have 3 of them, and then we come to the problems, and we have lots of them. I'm actually working with a customer in Munich, and I'm not kidding. They have over 1,200 functions in their database. You know, the reason is the software is a very old software. It's nearby older than me. And they started with so-called ESUM databases. You know ESUM databases like Paradox, DBase, and this kind of databases. And yeah, then they moved it over to a relational database, but they never changed their behavior to develop these systems. So they were always, and every single time, they were oriented in a so-called row-based operation. And this is something what you never should do when it comes to relational databases. So when we discuss the problems with the user-defined functions, I want to show you what Microsoft had done since SQL 2016, 2017 to improve the problems we are having with user-defined functions. What is a user-defined function? That's the first question. So most of you know it, so we go very quick through this. A user-defined function has been introduced in SQL Server 2000 the very first time. And I'm honest, when I saw this, I was so happy with that, because at that moment, we were starting a development project with a customer in Germany, and I used it heavily, because for one simple reason, I did not know what I do. And the cool thing with functions is because I'm coming from a procedural development language, like Visual Basic, maybe a few of you know it, or C# or C++, and I was oriented by tell the software what to do. But relational databases work in a completely different way. You do not tell how they should do this, but you tell them what you want to have. And this is the big, big, big difference. So when it came to user-defined functions, I was quite happy about that, and we started developing with this. It's the same as functions in programming languages. So user-defined functions are routines that can accept parameter. That was one of the highlights what we had. It can perform complex calculations, or it can return tables. So the key point for user-defined functions is that they allow modular programming. And from this point of view, I think it's absolutely reasonable to have user-defined functions. The second sentence is a commercial from Microsoft. You see it because I have the can in it. That is my favorite topic. Whenever a customer is coming, hey, what do you think about it? I always say, it depends. And this is a guarantee to earn a little bit more money. Yeah, and that's the same here with the UDFs. They can reduce network traffic, but that is a clear thing, because what is a user-defined function doing? We are calling the user-defined function on the server. It gets executed on the server. Yeah, and that's it. So that's true that UDFs can reduce network traffic. But primarily, it's so that when we're using user-defined functions, when I talk to developers, the main sentence from all of them, Dzień dobry, the main sentence from all of them is, we want to have reusable code. And that's a valid point, especially when it comes to big, big database projects. So especially, for example, the software which I'm dealing with. Another thing to use user-defined functions is security. Because when you do not give access to the tables directly, then the best way is to use stored procedures, views, or what you can do is you can use user-defined functions. Anybody here is familiar with the concept of security? Do not give permissions directly to tables, give it to views, stored procedures, or functions. Yeah, that's a typical thing from Microsoft. When they invent something, what seems to be pretty cool, the first thing what you always have to think about is there are some limitations with this. Always. So we have some limitations and restrictions, and here are the few points. They cannot perform actions that modify the database. I think it's clear that it cannot do this. It cannot contain an output into. That means when you have a result coming from a function, there is no possibility to use it like an output into a new table, something like this. It cannot return multiple row sets. I'm very sorry about it, because I would like to have it like we have it in stored procedures. It cannot support try catch error or raise error. It cannot call stored procedures, but what it can do is it can call extended stored procedures, XP underscore and so on. Yeah, we cannot make use of dynamic SQL, for God's sake, and we cannot use temp tables. Instead of temp tables, you have to use table variables. One of the baddest things you could ever do. We cannot use set statements, and for God's sake, we cannot use XML. Anybody is using XML? Is working with XML? Oh, you're my hero. I try to convince you to work with JSON. That's way easier than with XML. So we have three different types of user-defined functions. The first one, what I want to introduce to you, is SCALAR functions. Oh yeah, you see TV is here. Yeah, hello to the world. Thank you. SCALAR functions. SCALAR functions are very popular in databases when I start with them. SCALAR functions return just only a single value. It's a typical thing for a mathematical operation, or when you want to investigate some information like give me the number of orders, what a customer have, and so on. SCALAR functions return just only a single value each time it's invoked. So you see here an example. What we have, we say we create a function orders per customer and year, and we hand over two variables. And after the definition, we have to declare the return data type. In this case, it's an integer. Then we start inside the begin and the end with our operations. And the last thing is that you have to return the variable what you have defined as an output variable. That's very simple, very easy, but there come lots of problems with this. So we define the parameters, we define the data type for the return, we put our complete statements into the begin and end block, then we do some operations, and we finish with the return. That's it. But there is one big problem with Scala functions. One of the biggest problems you can see here, we have here a screenshot of my CPUs, and I was running a simple select statement, and it returned 1 million rows. And you see what my CPU is doing there. So people may say, well, that's okay because we paid for the CPU, let's work. But the problem is, think about this, let's say 100 processes are doing exactly the same. Then we will definitely run into problems. So when functions get used, then you could, Scala function, then you could definitely calculate a higher CPU usage. So another thing, and this is what I hate this. I hate this. It's the most horrible thing, iterative invocation. That means that developers are, and in this actual software I have this situation, from this 1,200 function, they have a function call, inside the function call, another function call, and inside this one, another one. For me, it's good because it takes 1 day to investigate what the fuck, what the peep is this function doing, by the way. And what they are doing, instead of using CTE, they are calling the function recursive. So inside the function, they call it again and again and again for getting an iteration. Another problem is the lack of costing, and that is something what I want to demonstrate to you. When we compare a regular set-based execution plan with some where we have a function in, you will definitely see that the call of the function will always be cheaper than a set-based operation. And the reason is that SQL Server cannot calculate what will be the costs of the function inside. But I make it visible. I will show you how it works. Interpreted execution, and the last one, and this is something what I sometimes really like, is the so-called serial execution. Think about this. You have a big query, and you do not have any functions in it, and the costs for this query are so tremendous high that the execution will go in parallel. That it means we take 4 or maybe 8 cores, something like this. So your query is running, and it's quite fast because we are using lots of CPU, and then you put a function in it, a Scala function in it, and suddenly your statement will never scale again. The reason is that whenever you have a Scala function in your statement, SQL Server will automatically create a serial plan. So there is no more parallelism in it. In 3, 4, 5 times I used it because I didn't want to have a parallel plan, and I don't want it to use the option max stop. So that gave me the opportunity to force my execution to go into a serial plan instead of a parallel plan. But Microsoft did some changes for this. Let's do some demos. I think it's way better than just only hear what I'm telling you and see this funny PowerPoints here. So here we go. So what I have some I've prepared something. Can everybody read this? Is this, the fonts are large enough for everybody? Thank you. That's good. So I have my database set up, and the first thing when we're starting with this, I want to demonstrate how Scala functions are working before SQL 2017. So what I'm doing now is I set my database to a compatibility level of SQL Server 2014. Yeah. I heard some rumor that some people are using 2014 or even SQL 2000. Anybody is using SQL 2000? I do. So the feature, to make sure, I switch it off, and here we go. First part, the preparation. What I'm doing is I'm creating a environment where I have 2 different tables. One is the customer table and one is the customer orders table. We have 75,000 customers and 3 million orders in it. I put an index on it to improve the performance. So I made a primary key on the customers and a primary key on the customer orders. And then I put another index on the customer ID and the order date because I want to count the numbers of orders given by a specific date. So that's it. Here is my core query. This is something what I see very often, and I think that you are quite familiar with this. I'm using an outer apply. It's the same as a left join, but I can invoke variables into the subquery. That's the reason why I'm using an apply. And the query is very primitive. I say, give me the name of the customer, and then give me the extract or the calculation of this query, which is the number of orders for every single customer. And what you see here is that I put in from the outer table the customer ID. Quite simple, very primitive. I want to have it for 1 year, and I only want to have it for one single customer. I switch on the execution plan and run this. So here we are. That was very quick. Okay, I have 8 cores in my machine, but it doesn't matter because it's going in serial. Here's my plan. And it's very straightforward. It's very simple. So I make a seek on the customers because I have an index on it, and then I do the aggregation on the customer orders to count the number of orders. Very simple. I compute SCALAR on it, and it goes into the nested loop, which is the left join and the output. Very funny, very simple. Here is my statistics. And what we can see here is that we had to go through the customer orders. It's using the index, so we have 3 logical reads. We move through the B tree, receive them, finished. Same with the customers, very simple. And now the disaster starts. A developer saw this and say, oh my goodness, I don't want to reuse every single time this big query. Let's put it in a function. That sounds to be so easy because Microsoft has invented it in SQL 2000. And then they did. So here is my function. And you see that the function is exactly the same. Oh, I have to go out for a smoke. So I create a function which is doing exactly the same. It's just returning the number of orders and given by a customer ID and a specific year. So compile this, done. And then we go again for this. Statistics IO on. Here is my first query. This is the use of the SCALAR function. Here, this one. You see this here that I put it into the output. And for comparison, I see here the same as a set-based operation and action. Seems to be incredible fast. Wow, you would say, come on, it's less than a second. Let's have a look to the execution plan, because the developer wanted to convince me that functions will always be better than set-based operations. I go into the execution plan and I see this. And for sure, the developer proved me by evidence that the use of the function here is way cheaper, 7%, than the set-based operation. And now it's on you. You are the DBAs, right? What arguments you have for them to tell them, no, it's not the best practice what they're doing. What is the biggest problem here? The problem itself is that SQL Server will have no chance to calculate the costs of the function. So the only thing what you see here is a compute SCALAR, and this is undefined. We do not have any idea about what's going on inside the function. So this is the reason why SQL Server think, hey, come on, I just only have to access the customers table, but not the customer orders table like it is here. This is the set-based operation. This is the function here. So when I look into the messages, again, it proves me by evidence. It say, well, yeah, I was accessing the customers table. Seems pretty straightforward. But have a look to the CPU time. CPU is exactly the time what the process is hooking on the CPU and consuming CPU. And this is the complete runtime, 105 milliseconds. And when I look to the set-based operation, look to this. Absolute, it's 0. Why is SQL Server consuming so much CPU when it comes to a function? The reason is every single time when a new record gets executed, it has to execute the function again. And the function means to invoke, compile, analyze, execute. And this is what happens within the 47 milliseconds. The reason why SQL Server is thinking that the use of the function is way cheaper than the set-based operation is very simple. The cost calculation is based with the majority of the costs for I/O. So I/O is the driving cost operator. And what we can see here, and then it makes sense that SQL Server will say, well, yeah, that's way cheaper. SQL Server do not consider the customer orders table while we are doing it here in the set-based operation. So you see here that the customer orders is here in, and look to the logical reads, it's 46 IOs. And this is the driving cost operator. So therefore, that makes sense that SQL Server will think, well, this one, the set-based, is way more expensive than the functional. But unfortunately, and this is what I see very, very often, it's not to blame developers, but when it comes to development, most developers I know, they are so super perfect with their front-end development or API development. And they do not really understand what's going on SQL Server. So they develop their functions and think, wow, that's very, very simple, very cool, and very cheap. But what's going inside, this is the problem what they don't see. Let's make it visible. So we are going with 500 clients. And now I make the real problem visible. What I'm doing is I create an X event. It's a preparation here, and it is there. Let me show you. I go here into this track SCALAR functions. What I'm doing here is I'm recording every single time when a statement gets compiled or gets executed. So let's see the live data. And then we go through the process again. First of all, I take one single record. One single record with the function in it. Go for it. And now let's see what's going on behind the scene. And what we see here is, that looks now completely different. Because what we see here, this statement starting, which one is it? It is the semi-original select statement. So think about this. We are starting our statement, and then SQL Server say, oh, stop, I need to execute a function. Because now the first record appears. And now you see what the problem is. You see here that SQL Server say, okay, I need to start my function, and then after this, when I executed it, you see how much time it was consuming. And this is something what we didn't see before, or what we don't see in the execution plan. And now you see the logical reads in it. So now we are aware of the access to the customer orders table. Do it a little bit more worth. Here, it's smaller than 5. First, let me delete this, clear the data, and run this query. So 5 records will be returned. My live data will improve this, will prove this by evidence that now I have 5 function calls. And every single time we are consuming CPU, and every single time we are consuming I/O. So this is everything. This is all working behind the scene, and this is what the developers don't see. And with respect, I would not expect that developers would use extended events to prove their performance. As a predicate, it is an absolutely nightmare. So I see it because I do not take this example only to show you some, hey, that's very cool. No, I saw this in reality. And to limit the output, because otherwise my SSMS will be broken, because then I get 75,000 calls, I reduce it to 100. Here is my query. Give me all my customers with an ID which is lower or equal to 100, where the number of orders in 2019 is larger than 15. We have 2 problems here. The first one is, I think it's clear, we have a non-searchable argument now here. So if we have an index on this, it will not work. And the second thing is, what do you think what SQL Server now has to do? We are filtering by the ID. We get 100 records back. And for every single record, this function gets executed. Let's prove it by evidence. And action. So we get nothing out. That's okay. And when we look to the execution plan, so the developer would say, oh my God, that's so fantastic. Yeah, but then it comes to this. Yeah. And I promise you, you see here 202 events. There is start of the execution, finish of the execution. 100 times 200 execution, 200 calls. Heavy, right? And this is something where you can convince the developers not to use SCALAR functions. This is one of the reasons why I try to avoid them. But as I said, back in the year 2000, I was young, I needed the money, I was homeless, I had a family, I needed to feed them, so I said I use them. And the good thing is nowadays they come to me and can say, improve my queries. I say, no problem, I need 2 days to do that, and another money is coming back from me. So what can we do with this? 2019 brought let's say, a solution for this. In 2019, we had the new feature called automatic inlining. The good thing here is it is not an enterprise feature. You can use it in all editions, for God's sake. The goal of the SCALAR UDF inlining feature is to improve the performance of queries with one simple idea. Look what is inside the function, and if it is possible to draw it back to a set-based operation, then take whatever it is in the function and make it part of the set-based operation. That is the key point what SQL Server wants to do. But again, we have some requirements and some restrictions. Why not? Right? So the basic requirement is that we have a select inside the SCALAR function, not only just a set variable equal to 1 + 1, something like this. There must be a select, so we need to access a table, for example. If then else branching is allowed, and there must be a return value, at least a return variable. That is the basic requirement. When this is inside, then it could be that SQL Server can turn the row-by-row execution into a set-based execution. But there are some restrictions. We cannot allow so-called non-deterministic functions like getDate, new sequential ID, something like that, which is unpredictable at the point here. We cannot reference to table variables. An order by is not allowed. No reference to user-defined types. This is something what's quite annoying, really annoying. I always ask me, why the heck, what they are doing? And there is no allowance for common table expression. Let me show you how this will work now in modern systems. So we have exactly the same. I leave it, I have the same function. And the only thing what I'm doing is I'm switching my database to 2019, or in my case here in 2022. I switch on SCALAR UDF inlining, that it is allowed. So that's the default when you're with 2019. And then we go. Here is my first query again. This is the query what we want to execute. Very fast, very clear, and very simple. And you can see that it is set-based as we expect. So now check our function whether it is possible to use this as an inlining function. Therefore, you can ask the SysSQL modules to check your functions if it is possible to use them. And you see, is it inlineable? It's a yes. Great. Okay, now I start the event again. One moment, like this. Watch live data and look for this. Here, first thing what I'm doing, I want to show it how it was before. And for God's sake, there is an option to disable inlining. As I told you before, sometimes for me it was necessary to have a function in it to avoid parallel query execution. So if you don't want it, then you can use this hint. And I say here, well, I want to disable it. I don't want to use this. And the next thing I say, yeah, run it with inlining. So let's start this before and after. So they both are quite quick. When we look to the execution plan, you see this is again the same behavior as before. But now, the second call, you can see here that SQL Server now is using my customer orders as a set-based operation inside the whole plan. And that is something what you can see here. That was not a good idea. Let me check this again. I just want to show you. Clear data and run this again. What will happen here? It's very simple. Look to this. No more explicit execution of the function. That's so great. Oh, I love Microsoft for this 2019 feature. And I wish that this could have been implemented way earlier. However, this is how SCALAR functions can improve your application when it comes to 2019. And before you set the compatibility level to 2019, prove it. It might be that you will have some degradation in your execution plans when it comes to the set-based operations. So yeah, you can disable it by using the hint. So if you really don't want to use that, then use disable T-SQL SCALAR UDF inlining, and then it behaves like before. I did it. So this is the improvement. You can see it here. Formerly, it was a compute SCALAR operation. Dzień dobry. Ah, yeah, a few people are coming in. You never missed anything. It's just only the commercial thing. No? Yeah. I'm addicted to commercials. You're welcome. So, since 2019, it's set-based, and that makes way more, that gives the, in most cases, it will improve the query performance. This is the horror of any database, of any SQL database. Multi-statement table valued functions. Who of you is using this kind of functions? Oh, come on. Do you even know whether you're using it? If not, let me demonstrate. Let me first of all explain what it means. A multi-statement table value function means that you have a multi-statement complexity in your function, and you see it here in this example. Come in, it's for free. And I heard you paid for it, right? Ah, okay. Okay. So what you can see here is I create my function. I hand over the variables like I did before. So here I have an order ID, or order number, the customer ID. And what you can see here is that I say I return a table. So I make it explicitly clear that I want to return a table. Do you know what is one of the biggest problems of table variables? It's the estimate of number of rows. Maybe you heard about this, yeah? So it's a guessing game. That was one when it came to 2012. And then in 2014, Microsoft thought they said, oh, we did a so great improvement. They increased to 100. That's so stupid. 100. What is the difference between 1 and 100? Yeah. However, but this is one of the biggest problems we have with table variables. Think about a multi-statement table valued functions like a table variable. The output is a table variable, nothing else. So what we're doing here, we are declaring that the return, the structure of the table we want to return, and then we insert into this table, just here in this case, a primitive select statement. That's very easy. And then we return. We do not say return table or return variable. No, we say just only stop it, go out. And this is the core concept of multi-line functions. I see it, I would say, when I do some improvements, or when I do some consultancy services, because it's performance related, and I see these kind of functions, or even if I see functions in the database, I never have seen less, or let's say it other. I have seen mostly when it comes to table functions, multi-line functions. And the reason is very simple. Think like a developer. Basically, if it's not a database developer, they think, first I do this, then I do this, and then I do this, and then I do this. And the funniest thing, what I've ever seen, is they fill the table variable with lots of data, and afterwards say, delete this, if that, delete this, if that, delete this. I said, gosh, what they are doing there. Yeah? And this function is called 1,000,000 times in 24 hours. We saw it with Query Store. We said, gosh, what they're doing there. Yeah. So let's see what we can do. This is the one and only problem we have with multi-line variables, multi-line functions. When we came to SQL 2012, you said it, that was correct. You said the estimated number of rows is just 1. That is funny. Sometimes it's okay. A good friend of mine and a colleague, Milos, I I cannot pronounce the last name. Yeah, he yeah, yeah. He explained to me that he was so happy about that because they wanted to force a so-called nested loop on the operation. Because when the estimate is so low, then SQL Server will say, well, that's easy. If there's one row, then I need to access the join table just only for one row, and I take it with a nested loop. That was his intention. So that was the only thing, or the only explanation where I thought, it makes sense to have these kind of functions. So then 2014 to 2016, Microsoft made a great deal. They improved it. They were going from 1 to 100. And we were so happy about that. When that have been pronounced, I said, yay. Yeah. Even a recompile does not work here. So what can we do? What we did then, when we wanted to improve this in the development, we put that into a temporary table. And then we had correct estimate. It is so cool when you have a job where you say, okay, every month at the end I get my money and it's completely useless whatever I do. The most important thing is to stay 20 days a month in the office to do some developments. Then it is okay. Demo. Here we go. I close this one. Yay, come on. And this one. Multiline. And this is a cool feature since 2019. I love it. It's very cool. Here we go. I go into my demo database, and here is my function. To understand what happens now is this function is accessing a table with 240 million rows. I have stored for every single city for a dedicated time the temperature, the average temperature measured there. So it's Internet of Things part, and here's my function. I hand over a city name, a start, and an end time. And then I say, please return for every single measured time the average temperature. Very simple. And you see that I can assign a primary key to the output table. Very simple. And here is my query. I say insert into my table, and this is my select statement that's coming from this database, where I hand over the city name, the start, and the end time. So that is my function. Action. Good. Hit no count on, it's okay. Statistics. Here comes the behavior with SQL 2012, and to make sure that that we run into problems, I do it like this. You can see here that I do an order by. That means the sort operator. Sort operators. It's important that it knows how many rows will come back. And what I'm doing here is I say, how does this query work in 2012? You remember, estimates is 1. So what I'm doing is I'm just getting for New York for 1 hour the values. With execution plan, action. Here it is. Oh, that was fantastic. That was incredible fast. We got 61 rows back. Look to the execution plan, it would say, fantastic job, Microsoft. Why? Well, the seek is coming from the CTE, where I grab the city name. And then I say, for this city, please go into this function and please have a look to the estimates. This is important. SQL Server is saying, well, I have 61 rows, but I was thinking there was just 1 row coming back. And this 1 row coming back means, from the sort perspective, that SQL Server need to allocate memory for this. Every stop operator, like a hash operator or a sort operator, requires memory. So when I go to the select statement, I can see that SQL Server here, they see that the memory grant is 1 megabyte. That's the minimum. But this is okay here because 61 rows. Oh, come on. Yeah, 1 megabyte is okay. Let's make it a little bit more complex. See what the behavior is in SQL 2014 and 2016. So I run exactly the same query, go into the execution plan, and here the function is exactly the same, but here is my one. Oh, did I have the sort? No, I didn't. Do order by. Yeah, so order by. Where is my sort? That's funny. Well, need to investigate it. And here is 2017. So again, for 1 hour for New York, my city list. So I go for 2017, and you see the behavior is exactly the same. SQL Server now, ooh, it isn't. Suddenly you see this, come on, here. The estimates are perfect. So 2017 made some good improvements. What is it behind the scene? Let's try it again. Here now I go for the 2019, but there's nothing changed. 2017, 2019, it's behaving exactly the same, so they get 61. So with 2017 there were some changes coming in. So let me see, this is measures. Yeah, I showed this, but here comes the problem. See this, and please notice the time range now. It is 10 days. So we are not getting back just only 60 rows. We are getting back over 14,000 rows. Every single minute we got a temperature measure. And now let's first of all see how it behaved in 2012. So before the improvements. And here you can see now what the problem is. You see that the sort operator had this little tiny, exclamation mark in it. That means, oh, I have a problem. He was puking. Yeah, so what did happen? Well, SQL Server was thinking there is 1 row coming back. But in reality, there were 14,000 rows coming back. It's the same as when you go with a knife to a shooting. It doesn't work. So you see that here the estimates is depending on this one single record. But Microsoft made a cool improvement. They said, hey, we understand this is way too less. So in 2014, they changed it from 1 to 100, but the problem is always present because 100 is way too less. First, with 2017, they came with the right technique. Now it's finished. Yay, super. So 2017 is a minimum you should have. Here comes the most important point. Your database must run in 2017 compatibility level. For God's sake, there are so much vendors outside who say, no, my database has to run in 2008 compatibility level. And we are so happy that we had bought the newest shit and we installed it and we are so happy about it. And then the vendor is saying, no, we do not support it. You know, to be honest, the only reason why they say it, they could say in the same way, we do not have any idea. But it's like it is. So let's look behind the scene because that now is interesting. What did Microsoft do to improve this? Let's look into the details of so-called interleaved execution because that is the trick. What is SQL Server doing? And to understand this, what the improvement is, and what the really cool thing here is, I have again an X event which is recording exactly what's going on behind the scene. This is the only possibility to understand how interleaved execution will work. So I go with my demo database. I leave it as it is. I set it to SQL Server 2022 compatibility level. I set the interleaved execution to on. And here I set the row mode memory grant feedback to off. That means maybe you heard about that yesterday when you have attended Ola's session. This is one of the improvements. Row mode memory grant feedback does mean that SQL Server will automatically adjust the memory consumption when it comes to an overflow. When it say, oh, we did a wrong estimate, we need to increase or reduce the memory. It's a good feature, but here I want to switch it off. So done. Here is my multi-line UDF. I watch live data. I want to see this. And I clear my cache. Here comes the first. How it did work before the new feature was coming into the game. They say I disable this functionality and I run this query for 10 days. I go for this, execute this. Yeah, looks very cool, but have to look to the live data. It now looks very complicated, but it isn't. I will show it to you step by step. First of all, think of this. What is SQL Server doing? One moment, the clear cache, that's okay. Here. So this is very interesting. It is an ad hoc statement, which means it's not prepared by a statement, by a stored procedure, anything like this. And what SQL Server here is doing, it's creating a so-called post-compilation show plan. What does this mean? The architect who is designing your execution plan has now an idea about how to execute this query. But think about the estimated rows. SQL Server, also we never touched our query, said, I think there will be 100 rows coming back from the function. Also, we never touched our original query. That is the key point here. So what then goes in is we put this into the cache. So now the architect knows or thinks there will be 100 rows coming back. First step. Now, after we do this, we are starting our query. Shit. You see what the problem is. The architect was way too early with thinking, oh yeah, there will be 100 rows coming back. It's completely mess up here because now look to this. So when the statement is starting, after the compilation, here is the truth. It is 45,000 rows. And now it's standing like this. Whew. Nothing else. So we put this into the cache. Now the statement is starting. You see this? Now we put the data into the table variable, but we have planned with 100 rows. So we came back with 45,000 rows in the table variable. So now this is completed. We do the return. That's it. And here we are now going to execute. Oops, come on. There is something coming in between. Here it is. So now I finished my original query. What the heck is going on here? And this was always the biggest problem with this. So Microsoft were thinking about this. Clear the data. So Microsoft were thinking about it and said, what can we do better here? The only thing can make this one going well is that we tell the architect, hey, do not guess before you start the statement what will be returned from the table function, but wait with it until we start the whole statement. So we turn it a little bit. Or this is one option. The second option can be that we tell SQL Server, hey, come on, instead of guessing, execute this. And then you know the exact values. And with this value, then you can create the plan for the original query. Let's see how Microsoft has implemented this. The same query, no hint. Let me see, is it clear? Yeah. So I run this query, action, was very quick, and we go into the live data, and here you see now what happens. I increase this, one moment. So look to this. There is a huge difference in it. SQL Server is first executing my table valued function. It comes back with the original, with the correct estimated number of rows. Say, okay, we put this into the cache. Now we start this, and we came back with 45,000 rows. And when the function is completed, then SQL Server checks, can we use these values because it's an interleave function? It say yes. Yeah, here we get the update. It say, okay, yeah, we can use this. And then you can see it right here. We now can start with the execution of our original function. That's a pretty cool thing, isn't it? I love the way how it works now in these modern times. So let's check it with the execution plan. And you can now see that the sort is really, really perfect. We have the exact estimate, the sort operation. Dzień dobry. And what SQL Server now was doing, it was calculating the correct amount of memory, so 2 megabytes. I love this feature. That's a cool thing, but it's always, you have to have SQL 2017 to use it, at least 2017. So if you're in 2019, 2022, you're super. But you must be aware that your database have to run in compatibility level 2017. So do you have any questions so far to this? Do you have fun with functions? Fun with flags? Fun with functions? Yeah? Okay. So last one is when it came to multi-statement, multi-line functions, the paradigm shift was coming with SQL 2017. In SQL 2016 or prior, the problem was that the function has not been executed before the statement, so that is a poor guessing game. And what was the recommendation from every developer or every blog post? It'd say, when you're using table variables or multi-line valued functions, do not use it with big amount of data, just limit it to 100 or maybe. And the reason is clear, because the maximum has been estimated was 100 rows. So with 2017, first time the so-called adaptive query processing came into the game. And the core concept of adaptive query processing is this. Think about an architect. Think about this. You want to build a house, and then you were going to an architect, and this is your query optimizer. So you're coming to the architect and he's asking you, hey, what would your house look like? And then you're starting. Oh, I see my house at a beach, lots of sand, a big window where I can look outside and then see the ocean, and the sun is coming up and saying, hi, Uwe. Something like this. And what you see is that the architect is permanently writing down some information about this. And one of the key points is that I told him I want to have a house at the beach, so very sandy and so on. And what is the architect normally doing is say, okay, Uwe, that's fine. Come back next week. I have the plan then ready for you. So what the architect then is doing, it's creating a cost-based plan for me. And in this cost-based plan, there is information about how many people should work at that house, how many people we need for the roof, for the basement. Yeah, that's good. Okay, and so on. And then he thought, okay, that's very easy. I need one person to prepare the ground because it's sandy. So I get my plan. We're coming, or then the construction company is coming. And now they see the disaster. I was planning for the beach, but my house is in the Alps. And what is the biggest problem now from the perspective of SQL Server? We cannot change the plan. So that means when SQL Server has decided to use one person for the basement, we cannot put more people into it. And this is one of the biggest problems we had since SQL 2016. So that was when the plan was going out of control, so that when a query takes very, very long. So what Microsoft then did was, with 2017, with the adaptive query processing, they changed the behavior of this. What they did is they said, okay, first do an estimate, and when it comes to reality, then change it if necessary. Maybe you've heard about some topics like adaptive joins. Have you ever heard about this? Adaptive joins, data warehouses, that mean that in the runtime, SQL Server can definitely switch between a nested loop and a hash operation. So when it comes to more data, SQL Server then can decide quickly and say, no, I take this one because it's easier. And that came with 2017. And one of this is with the functions. So the core concept is that the executing of a part of the query now is during the execution plan creation. That's a really cool thing. Memory grant, adaptive mode, adaptive join operator, and so on. In 2019, SQL Server was coming with UDF inlining, so user defined function inlining, and the table variable deferred compilation, but this is not a topic what we have here now. So here is it again with the wrong estimates. Why do we get the wrong estimates with multi-line functions? Very simple. We start with our execution of the original query, and afterwards we came with the function. But the problem is, at that moment, the plan was ready. That's the same as when I tell you something about I want to have a house at the beach, and my wife decided to go to the Alps. So funny. So interleaved execution, it's so far clear. And there's one thing what you have to know about interleaved execution. When you set it to on, when you want to use it, take into consideration that your CPU will slightly be increased. Not very much. What I've seen from my experiences so far is, let's say, 2%. It depends on how often the query the function gets invoked. So we have some extended events for this. I used this. So when I demonstrated it, these are the extended events you can use to monitor how the interleaved execution will work. And interleaved execution will work, yes. That's a cool thing. And last but not least, we have these kind of functions. And you know, you will say, what? Hey, come on, we just only have 5 minutes. Why is he using this one at least? Is it so simple, or is it... It's very simple. Nothing has changed. What does it mean? An inline user-defined function. It is nothing else but a view where you can hand over parameters to. That's an inline function. The good thing with an inline function is it just only has a return, and then immediately after it, it follows by a select statement. And here comes the good thing. SQL Server is treating an inline function exactly the same as a view. So it does not need to get into it and calculate it, but it takes the select statement inside the function and put it like a set-based operation to your query. So it's the same as when you join with the subquery. It's exactly the same. Think about this as a subquery where you can hand over parameters. That is an inline function. When it comes to functions, what I would always recommend to you, whenever it is possible, use inline functions. Even when it comes to calculations, I'm using inline functions. For example, I want to have, let's say, the taxes from a given value. I hand over the value, and I want to have the not the net amount, but the total amount, including VAT. And the only thing what I do is I say a select given variable plus VAT and return it as a table. Yes. Oh, an expert. The question was, or the question is adaptive query processing available in all editions of a SQL Server? No. No, it isn't. Adaptive query processing is part of Enterprise Edition. Yeah. Thank you for the question. So where did I stop? Yeah. So whenever it comes to working with functions, sometimes it's pretty good to have them, but try to avoid multi-line functions or SCALAR functions. When it is simple calculation, yeah, why not? It's okay. But think about when it is in the output or in the where statement, it needs to be invoked for every single record, and that will increase your CPU. So when you think of all about this, then you would be quite safe with functions. And here are the improvements we had. The red line is only interesting. And yeah, I think we are, oh my goodness, we are in time. It's the first time I'm in time. I hope you enjoyed so much, and I hope you enjoyed the conference. Thank you very much. So, dziękuję I do widzenia. Till next time. Thank you.